Um, okay.
Hello, good morning or good afternoon. My name is Haley, and I will be your host for today's webinar. Please go ahead and use the chat button at the bottom of your window to start to let us know where you are listening or viewing from. I'm coming to you live today from Connecticut. It's finally sunny and almost 70 degrees. And then we will go ahead and get started in just a moment. Hello and welcome, everyone. All right, with the first minute up, we will go ahead and get started. So again, good morning or good afternoon, everyone. My name is Haley. I'll be your host as we discuss today's topic, how to prevent invasive files threats in your security architecture. This is brought to you by Votiro and hosted by VIB. Today's webinar will be about 45 minutes long, the last 10 to 15 minutes of Q&A. Please use your Q&A button at the bottom of your window to ask any and all questions. We'll do our best to answer those questions, but for those we don't get to, we'll follow up after. And now, without further ado, I'd like to introduce our speaker, Seth.
Thanks, Haley. And thanks, everybody, for attending today. My name is Seth Hammerman. I'm a sales engineer with Votiro. We're probably going to talk about file-borne threats more than you've ever heard in your life during the session. So we'll try to keep it interactive and leave room for questions at the end. A little bit about me. I don't like to talk about myself, but no, this is all about me. I've been around the world a bit. I speak a couple other languages, and I believe in giving back to the community. That's one of the things I like about being in cybersecurity is that I feel that we're doing a service that the community definitely needs, because the attackers are getting smarter and more automated. And I believe that we need to keep our information secure. And I am geared up for the fight. So again, this is our agenda. We're going to learn about what file-based threats actually are. Maybe you've heard a different term for them, but we'll go deeper into that. Why are they so effective of deploying malware? How do they get past antivirus, sandboxing, EDR, and the like? We'll go into that too. And how can you protect yourself, your organization, your network from these file-borne threats? By being proactive and having a true zero trust approach. Now, I know zero trust is everybody's favorite cybersecurity buzzword, but we'll get into that a little as well, because I know that I always say that Votiro is true zero trust because we sanitize every file that goes through our platform. And hopefully you'll get to understand how that works a little bit over the next 40 or so minutes. Okay? All right. Again, why are these file-based threats so good at evading these detection systems and deploying their payloads? Malware. They exploit vulnerabilities. What that means is, who do you think the number one software vendor in the world is for vulnerabilities? That happens to be our vendor that produces Office 365, Microsoft Word, Excel, PowerPoint. You've heard of Patch Tuesday. That's to keep up with all those vulnerabilities. So the bad guys are constantly looking for ways to exploit different vulnerabilities in software, operating systems, and so forth. And once they find a way in, they will keep at it until they have a breach. And even then again, they'll keep attacking the same network because it's an easy target. So once the bad guys get in, they're in. And how do they get into my network? How do they get into my company? there's a bunch of different ways that they can get into your company. Probably the most popular is email, but there's other ways that files get into your company as well. File sharing platforms, malicious websites when a user downloads something where they shouldn't, and then a common ploy is the bad guys will use social engineering to make you click on that email to open that document. These are examples, to enter the password and thereby enable a macro or whatever to deploy their malware and let them land and expand. And again, we said they're experts at getting past these traditional security measures. Antivirus software, probably the biggest one that they're going to get by, but other tried and true detection methods, they're getting by those as well. And hopefully we'll get into that a little bit, show you how it's done. So what are these 0-day weaponized content files? I mean, that's a lot to say, isn't it? So let's see if we can't give some examples here. So again, usually what I've been seeing is Word documents, PDFs, PowerPoints, Excel files, also image files, and recently multimedia files. And the common thing about all these files is that there is a known or a previously unknown vulnerability by the manufacturer, but known to the bad actors out there, that they can exploit that vulnerability to get into your machine or to get into your system, and then just, like I said, land and expand. Here's some examples on the slide. I think this is probably chronological order. They started with PDFs having, let's say, like malicious JavaScript in them that could get past antivirus. Weaponized Office documents, we'll talk about that a lot. We've been seeing a lot of that. Word documents with macros, and Microsoft now is disabling macros by default, but a lot of businesses use them and depend on them. So, there's the catch-22. There's other ways to deploy malicious code. All you need to do is be familiar with Kali Linux and Metasploit, and you can build your own. We'll talk about that too. And audio, video, or picture files that can contain hidden malware or hidden executable files within that picture file, that once you open that picture file, the executable is activated, goes to work. The whole idea of this is just to have a never before seen vulnerability. That's what we mean by 0-day. So, I'm getting ahead of myself, but we'll talk about that. So, a never before seen vulnerability. So, VirusTotal hasn't seen it. The major manufacturers haven't seen it. So, they can't defend against it. And usually it takes a few weeks for it to show up. By that time, the cat's out of the proverbial bag. Again, I said we'd be talking a lot about this. So 0-day attacks, it means there's a new vulnerability that's been discovered by a software vendor or a platform. And then from that 0-day, the clock is ticking for that manufacturer or the manufacturer of the operating system to come up with a patch. How long can this take? We talked about Patch Tuesday. It can take a couple of weeks to a couple of months. So the onus is on us to defend against these file-borne threats. And how do we do that? And how do we be proactive when, our antivirus hasn't even seen it, doesn't even have signatures for it? Right. And the last button about how attackers have learned to hide malware, all sorts of garbage, all sorts of nasty files, attack vectors within like harmless looking Office documents. You would think, wow, it's a Word document. What could be wrong with it? It's PDF, right? How is it evil? And let's take a look at that. This slide, I think it's good to talk about just kind of the timeline of 0 day, because it gives you a window into, what happens when, let's say, Microsoft discovers a vulnerability, or I don't know, there was a flaw in open source software that was developed. All these types of vulnerabilities are discovered, right? And then we discover an attack against that vulnerability. So that's when the exploit is released. So then there's a timeline. We discover the vulnerability and we disclose it. We talk about it on all the popular venues. And then the vendor is going to develop a patch and release it. And then it's time for Patch Tuesday again, or updating whatever software on whatever platform or device is affected. And that can take a very long time. This is a quote that these 0 day exploits have an average of 6.9 years of life expectancy. So that means once the exploit is released, being able to counterattack all of it and find it in every network and patch against it and defend against it takes all that amount of time. Yeah, it's kind of scary. I know. So again, why should we use files? I mean, isn't that why, why use harmless Word files, Excel files? Why use these as attack vectors? So again, this is a quote, Office files and PDFs, excuse me, their favorite. Why? Everybody uses them. I read somewhere a survey that 96% of files traversing corporate networks are Office files, right? Word, PowerPoint, Excel, and then PDFs. So, hey, it's a commonly used file. People are not looking for it to be a weaponized file. So, oh yeah, sure. Attach it to an email, open it up, right? Upload it to OneDrive. What could be the harm? Plenty. So this is another statistic. And oh yeah, 96% of these attacks are delivered via email, of course. And then content within Microsoft, Windows applications, website content. So you can see, I mean, years ago, we were all worried about dangerous websites, cross-site scripting, malware being delivered, but it's shifted now to a common vector that every company uses and needs. Who doesn't use email these days? Who doesn't need it? Right, everybody. And you can see all these these are all different ways that the files we talked about can get into your network. So there's a lot of different attack vectors. And true zero trust means not looking what you already have as a defense mechanism, as part of your defense and dev strategy, but looking at other vectors where files are coming in that you may not know about. Example would be, a contractor has been authorized to work with you, but needs to upload documents to, let's say, a OneDrive folder. And these documents can be weaponized. And they can get past whatever controls you have if you're not using file sanitization. And all you need is one. So why should I worry? I've deployed endpoint, DLP, antivirus, I'm sandboxing, and I'm doing patch management. So life is good. I don't have to worry about anything, right? Sorry to burst your bubble, but these traditional solutions, and I'm not saying that they don't have a place anymore. They definitely need to be part of your defense in depth strategy. But there are new ways that the bad guys are getting in, and that is by zero-day weaponized files. And again, like I say in the second paragraph, they deliver them via email. So, yeah, there are email protections. There are email security gateways. And yes, they do a job. They do their job for phishing, malicious URL detection and the like. But when it comes to weaponized content files, not so much. And there are different ways that you can deal with this. The end result is what you want is you want to have your files sanitized. In other words, you want to have malicious content removed, but you want the file still to be fully functional. And that's kind of like the catch-22, right? That's what you want. But that's what file sanitization does. That's what Votiro does. Again, why Microsoft Office? Because it's the most popular platform in the world for business documents, and people trust it. No, I trust my Outlook. I trust Word. When I open up a Word document that somebody sends me, and then I click on the little button where I want to edit it, even though Microsoft says no, I'm going to do it anyway, right? Why not? And that's where you can get in trouble. And we talked about exploitability. So one of the big ways we see is embedded macros within Word documents and PowerPoints and Excel's spreadsheets and a few others. These are a favorite of the bad guys to bury malicious code. And again, we talked about social engineering to execute it. Let me give you an example. Bad guys are using a targeted spear phishing campaign against your company's CFO. And the title of the email is always something urgent. Please open this password protected file. It has the new budget figures for 2024. And then in the email, you see the Word attachment and it's password protected. And in the body of the email says, I will send you the password in a separate email. That one gets through, of course. So does this email with the attachment, because password protected files are passed on by a lot of different systems out there because they just don't know how to process it. Right? We'll show that as well. It's like I can't open it up, so I can't scan it. So send it on down the line. What's wrong with that? Well, we'll see in a minute. So how difficult is it to create a weaponized Word doc? So I actually decided to ask ChatGPT. And you know what? It's all in how you ask a question. Your mother ever tell you that when you wanted something when you're a little kid? So I framed my question in a way that I would get a response, because ChatGPT is programmed not to give you this information because it could be used for evil. But if you know how to ask a question, you'll get a response. So, of course, it said using Metasploit. Again, I talked about it. It's probably one of the most popular open source pen testing programs out there, running on Kali Linux. So here are your recipe instructions. So you open up Metasploit. You use this auxiliary scanner macro command. You select this docx macro module within Metasploit, and then you can set your options. You can choose a payload to be buried within the file, and then you run it and you can generate it. And then once that document is generated, you can enable the macros and trigger the payload. Kind of simple, right? Of course, you have to have a familiarity with Linux, Kali Linux, and Metasploit, but hey, you can learn. So the point is, it's not that difficult. And on the dark web, they're actually selling kits where you can use software to do it for you instead of having to tough it out, compile the Ruby script, and pick the options. So let's talk about a new defense against this, weaponized file vector, file sanitization. So what is it? Basically, I don't like the word flatten. I got to change that, but we examine the file completely. We make a copy, and this is what we do at Votiro, of that document. We look for known good content. And how do we know known good? We have a process called true typing the file, but we also know by the file's magic number that is set in every file type that tells the operating system what type of file it is. We also know the manufacturer's specs. Believe it or not, there's about 20 pages of those for content within a Word file, and we'll get to that in a minute. Also, there are RFCs, if you know what those are. Internet requests for comments about format and structure of these type of content files. So yeah, you can go out and search it up. They do exist. So with that knowledge, we know what good content should be there. So we move the good content into the new file copy, and we keep malicious content or what shouldn't be there in the original, and we keep both files. We'll show you that in a minute. Previously known as content disarming and sanitization. It has a lot of different forms. So the important thing to remember is that we don't need to rely on detection, right? We're not looking for learned behavior. We're not looking for file signatures that would tell us if there's a virus or not. All that doesn't matter. We're truly zero trust and truly proactive in that we're just looking for content that is known good, and whatever shouldn't be there, we leave in the original copy and we don't move it to the new sanitized version. So wait a minute. Won't my email gateway protect me from these types of files? And like I say, the answer is maybe. First of all, it depends on how you configure your policies. Second of all, it depends on if your manufacturer supports it or not. This is I'm not going to name the manufacturer, but this is a shot of a configuration policy screen for a particular email security gateway. And you can see that, they support Microsoft Documents with macros to scan, but not Excel. So what do you do if you have an Excel document with a macro with an email? It might get through, it might not, depending on what's down the line, right? By default, scanning password protected attachments disabled. So That'll get passed on, kind of thrown over the wall. And if it's unscannable, then just deliver the message anyway. We don't want to hold up email. So again, email security gateways have their place, but they're not the be all and the end all when it comes to zero-day weaponized files. There are a lot of chances that these files are going to get through and wreak havoc in your organization. So a lot of the activity by a secure email gateway, when they do support the particular file type and they are macro enabled, they basically will kind of rip the macros and all out of the document. Let's say it's a Word document, create a PDF and just send that on the way. And that's fine. It's secured. But if it's not a malicious macro, it's going to get torn up as well. And what happens if that's a macro on a spreadsheet file? Well, it might get through. Or a macro in a Word document that's doing number crunching for the accounting department that somebody put months of work into. It's gone. So kind of counterproductive. The objective is to have a sanitized file, but fully functional. That's what we're going to do. So how does this process work? So I talked about it, but let's spend a little time here and look at it. And I promise you, I'm not going to kill you with PowerPoint. I will get to a demo, a couple of demos at a certain point. So just bear with me, because this is a pretty new concept. This has been around for a while, but for me, I've been here about a year, but I've been in cybersecurity for a long time, and I never really considered file security, weaponized files, zero-day content files, any of that. And so I learned a pretty good lesson and learned about the importance of sanitizing these files. How does it work? So we're going to look at the file first. We're going to disassemble it into object parts. And we're going to analyze it. And whatever good content is there, we're going to move over into a known safe only version. So it's copied. And we're going to reconstruct the full depth of macros so they work, if there are macros. Then we're going to test that file for file functionality to make sure it does. And then we send it along its way to its original destination, whether that's a user's inbox or a file upload folder, a box folder, a Salesforce support inbox. There are plenty of different ways that we can sanitize the files. How are we doing on time? We're doing okay. All right. Next. So this is what we do. We call it positive selection. Again, the theme is to keep the known good and leave behind the unknown or the bad. So it's kind of an animation of the slide before, but it's pretty slick. I like it. So we get that unknown file. And again, every file is sanitized. So we get that file, and then we kind of dissect it and look at all the content that's in that file. And there is a lot of content in a Word file, and you'll see. So third step, we extract the good content, the text, the layout of, let's say, the document or the PowerPoint, and we replace that known good, that whatever it is, right, with safe content. We process anything that's embedded within that file. Embedding executables, OLE objects, even URL links within Word documents is not unheard of and is kind of common. So we will process those as well. We'll look at the content directory, we'll replace it, and then we'll repackage the file. And then voila, we rebuild it. You've got that save copy. And then 100% save file is delivered. So we never have problems with false positives. Because when you think about it, false positive means I'm detecting something because I'm referring to some kind of evidence that says, okay, this is what to look for. So it's evidence of a virus being in there. We don't need that. So, like I said, we're true zero trust because we examine every file that goes through our platform. And there you go. So remember, I just said a couple of slides ago, what's in a document file, right? Isn't it just text? No, it's not. See, all of the executables and so forth, objects. It's not like opening up a notepad text file. There's a lot of stuff in there. Hang on one second. All right, so here's some stuff that I learned about file content basics, right? When I went into this. Take a look at this. So again, 98% of all corporate files are document files. Again, I think I beat it to death about functionality, right? And bad actors exploiting it. And again, we talked about the complex file formats. We talked about all right, good. So again, what's in the Word, a PDF, a Google Doc? It's a collection of multiple subfiles, XML, OLE objects that make up that file, that tell it what type of font to use, that tell it where the paragraph is, to tell it what style, all these different things, right? And here's a partial output from an open source program where you can actually walk a file and you can see, kind of lift the curtain a little bit and see what's behind that magic door and see what the content actually is. And I will switch to a live version of this if I can to show you what it looks like. So again, this is a Word doc that has a macro in it. And there's a suite of tools, OLE tools, and I'm using OLE VBA and Kali Linux. And I'm browsing the file. And you can see what's going on here, right? You can see what's going on and what the suspicious elements might be. Well, let's see if we can show you that real time. Make sense? Let's see. We're always tempting Mr. Murphy here, right? So this is Kali Linux, for those who are not familiar. It's a great version of Linux to learn because it has all of these open source penetration and testing tools. So I am going to look at that return to office.docum, which has the macro in it. I'm using OLE VBA like the slide. So look at that. Now, we're not using this. I can't tell you about our secret sauce, but this is a good way to look at all of this stuff that's hidden within just a simple Word document file. I don't know. This stuff amazes me, but your mileage may vary. But I mean, look at everything that's called out, all the different environments, right? And then what we find, right? What happens when the Word document is open? There's an Excel buried in it. So what happens when that opens up? There's some suspicious stuff in there. Like my daughter-in-law says, there's some janky stuff going on. So, this is something that you don't see when you're just looking at a normal Word document. You really don't see behind the curtain like this, right? So yeah, it's a good way to kind of get a view into file structure and how complex it is. So let's go back to the PowerPoint. I know, I'm sorry, but I have to. So this is a shot from a Votiro from our incident screen, just showing you how far things can be buried, right, within that file, and how we detect them and sanitize them. There's a zip file in here. There's a couple of executables, and then a little red dot means that we block them. Now, we also have policies in the platform to deal with different types of actions and different types of files. So what happens when we upload that Word doc to VirusTotal? The one with the macro? Yeah, VirusTotal. And again, this is kind of just a demo file. It really doesn't have a malicious payload. But when we upload it to VirusTotal, mostly 39 out of 64 vendors say, yeah, it's malicious. They flag it. So what happens when we password protect it? Nobody sees it as malicious. It just goes right through. And like I showed you in a slide about 5 or 6 back, some common platforms just don't even process it and just pass it along. So again, that's something that to keep in mind, that the theme of, hey, I'm okay. I've got all these traditional things. I've got AV. I've got, next generation firewall. I've got this kind of, nope. Not going to help you from stuff like this. Oh yeah. Okay. I show it again here. So you can see that, and I shouldn't call out the vendors, but they can't process it. So it just goes on its way. So we need to do something about it. All right. So let's see now. This is our system, right? Let's try and download a file and see what happens. Now, let me tell you what's going on here. This is the front page of our GUI. This is my little web browser plugin that I have enabled, and for demo purposes, I have it visible. You can actually see I was playing around with it before, and it's blocked some stuff and it's sanitized some stuff. So let's go and again, we tempt Mr. Murphy here. Let's see what happens. Let's download that document file. Oh, how many people have done this? Hey, I don't care if it's infected. Google's telling me, but what do they know? I'm going to download it anyway. So if you see the bottom of my screen, up, and look, I'll create an exception for that because my Avast thinks it's a virus too. Well, I don't care. I'm going to download it. So what's happened here? Let's go check into Votiro. Let's see a document file that was downloaded. Yeah, I've just been given the hold on one sec. I've just been given the kind of the hook. So I'm gonna have to move on real quick here. Let's go back to the PowerPoint. Steganography is an oldie but a goodie. It's a way of hiding malicious code within an image file. So, a standard JPEG photo contains a lot of pixel data, but it could also contain malicious code. So here's an example where you can see the malicious code buried. If you look at the hex of the file, then after we sanitize it, you can see that we've kind of obfuscated all that bad code and sanitized it. Let's see if I can go back to the demo for a sec and see if we can show you that live. Right, so let's do this. Let's do a manual upload of an image file. Oh, it's just a harmless file, right? So we're uploading it. And then let's take a look. We click on details. It's kind of a cheap and dirty way to do it, but it's clean. The metadata is removed. Wow, it took a long time. 2.5 seconds. So what was in that file, right? Let's open up the original one of it, right? So this is a common ploy, burying stuff within image files. Let's find the dirty version of that, let's say. I've got a lot of different test files here. I don't know, we're getting to the end, but I want to show you what's going on with this one. Here we go. Oh, wow. So it's not only an image file. Again, this is before we've uploaded it and sanitized it by Votiro. What happens when I click on it? It calls calculator, pops it up. Now, if this was a real bad file, it could have called some sort of malicious executable, and then the bad guys would be in and done and start to land and explain. So, hopefully that's just a real quick and dirty little demo of how we can sanitize files. So let's go back to the deck. Again, why haven't the legacy methods dealt with this? Again, they deal with predictive analytics. They deal with already known information out there, right? Signatures, learned behavior, and so forth. And again, a lot of people who deal with this day to day, it's kind of like, it's just kind of a matter of, it's almost, it's a practice, right? It's what they deal with. But weaponized files are completely different and are going to get around these traditional protections. Yeah. So again, this has been done before, what used to be called CDR, but what happened from that is that The content of the file is basically ripped out. Yeah, it's sanitized, but it's not functional anymore. So how do you mitigate these threats? Trust no file. And that's what we do. We sanitize every file. Just a couple of architectural slides. Now, we have offerings to sanitize files no matter how they're coming into your network via the browser, which you saw, email, or applications that we integrate with. Again, this is just an architectural example of our email connector, how we're sanitizing the email before it gets to its final destination. We even deal with password protected files. We can coexist with an email security gateway. So yeah, it can do its job. It can sanitize emails. It can do, it can look for, it can do, anti-phishing. It can do malicious URL detection, all that stuff. But when it comes to us, we're going to sanitize the content, the attachments, before it gets to where it's going. Again, you just saw the web browser plugin. And I think now we're at the Q&A section, yeah? Are we at the Q&A section, or can I go into demo a little bit more?
There are some questions, Seth. Do you want to take them now or offline?
Yeah, sure. Why not?
It says, hello, wonder how file sanitization is effective from encrypted files.
Okay. Well, instead of explaining, why don't I show you that? So like I said, Votiro will process password protected files. Let me look for one that's there we go. So this is a file that has a, here, let me open up my 30 days for that. Here we go. So we block it, we sanitize it. You can see in the sanitization log, it took half a second. But what happens if we want to see the sanitized version? Well, I don't want the original. I'll download the sanitized version. What happens is I'm going to get a PDF with your company logo on it saying we blocked this file adherence with security policies, whatever verbiage you want to put on it, but I have a password. So we need the password. We don't have a magic decoder ring to do this, so we do need the password. But once the user puts the password in, we can remove the file password after we sanitize it, if that's what your policies are. We can even deal with more than one password. But let's get the file and now sanitize it. So basically, we've got the password, we're decrypting the file, right? We're sanitizing it, and now I can download the clean file with the macro intact. Hopefully that answers the question. Okay. Any more?
So yeah, I want to highlight another question here. So the question is, if it's a criminal attacking with a malicious document, why worry about sanitization? If IT is doubtful that they would be using real files in their attack, why bother preserving the underlying file? Isn't it faster, more efficient, and safer to just delete the entire file outright?
If I understand the question, right, why not just block it entirely? Yeah. That's what's been done. But what happened? I mean, first of all, there's a chance that that file is going to get through in its state if it's a password protected file with a macro in it. It usually evades these type of systems. So we want to make sure that we sanitize that file before it gets into our network, right? You're right. If it's truly dangerous, we have the opportunity to block it. You can choose that in policies, but for productivity's sake, and also to make sure that, you know, we're sanitizing every file that goes through the platform, that's part of our method. In other words, every file goes through. And actually, to answer that question, we did block the file, right? So if you go back into the product here, you can see that originally we blocked the file. We kept it from going through because it had a password. But we download the sanitized version and we put the password in because, I don't know, we needed whatever was in the file and we want to have it sanitized. So yeah, if all you want to do is block these, you can do that in your policy. But if you want them sanitized as well, and again, this is one with a password in it. If it has no password in it, for instance, a file like this, we're going to sanitize it and the user doesn't even know it, right? The good thing to remember here is that we don't need any end user agent. So we don't need an agent on your machine. We don't have special hardware. We can set up an environment for a customer in our SaaS platform within minutes. I mean, there's no heavy lifting to do.
In that use case, Seth, it's signature based and known threats, right? We're not taking into consideration in that question or that use case unknown threats, right? Because we're blocking based on signature and known threats. Is that accurate to state?
No, this is being blocked due to policy.
Okay.
Right. What we do as a matter of course, right, is we will scan it. If you see the third bullet here. So to double protection, I guess, as a matter of course, we will scan the files with an antivirus engine. So we're looking, we're making sure that there's nothing done within it. And then we start the sanitization process, right? You see new child item created. That means we're rebuilding it into the sanitized copy. And we log everything we do. And we can send all this information to a SIM platform or other security platforms as well. So yeah, everything that goes through is sanitized. Let me go back into my PowerPoint here.
And Seth, we got a couple more questions, if you don't mind answering those.
That's what I live for.
All right. So does the sanitizer process for outgoing and incoming content?
Currently, in all the use cases that I've shown you, it's all incoming, right? We are more concerned about weaponized files coming into your network than what's going out of it. And what I've seen anyway, is that systems in place with policies and stuff and different tools will examine files before they get sent out of a corporate network. So our focus really is all the entry methods, right? I always ask, how do you deal with zero-day weaponized files coming into your network? How do you sanitize them? How do you make sure? And remember, it's nothing that's ever been seen before. So, There's no frame of reference. There's no virus signature that you'll identify the attack from. So no, we are currently, our use cases are focused on inbound files. I hope that answers the question. Could we sanitize outbound files as well? I'm sure we probably could, but right now our focus is on what's coming into your organization and however it's coming in. Could be an S3 bucket, could be email, could be box, could all these different ways. Okay.
So a couple more questions here. If an image file is transferred to another device from the infected email, does the virus go along with it?
So that's an interesting question, but again, we're not an antivirus platform. We are file sanitization. So if the file is, I showed you that image file, right? Right, that spawns off the calculator. It's really cute. It's buried in there, and then I showed you the sanitized version of it, right? Which cleans out all of this content. So once this file comes in and it's sanitized, if this user shares it with somebody else, they're sharing the sanitized version, right? As long as I've been here, and I said I've been here about a year, I've never seen us miss anything. Like I said, false positives don't apply in this case because we're not looking for something that is a reference. We're sanitizing everything, right? So again, with that image file, you just saw the dirty one that spawns off that hidden calculator exe, but you can see that we remove the metadata that does that, and the file's sanitized. Hopefully that answers the question.
And then I think we have time for one last question here.
Okie dokie.
So does Votiro have a cloud-based version, specifically Google Cloud?
Right now we're mainly hosted in AWS. We are also hosting Azure. We're not in Google Cloud yet, but there's no saying that we can't be. We're a young startup. We make decisions really quickly based on what our customers want. We started in AWS. One of our customers wanted us to host in Azure for their reason, so we developed the product for Azure. And if a large customer wanted us to host in Google Cloud, I'm sure that we could do that. Hopefully that answers that question. So I always say, when you come to the table, you can dictate what's on the menu. So if you are a customer, a larger customer that wants a certain feature or us to run on a certain platform, we're really fast moving. We make things happen. Hopefully that answers it. And thank you to the crowd for being really great and attentive. I'm sure there are ways to contact us if there are questions that we missed, or you want to see a more live demo, further more detailed demo and explanation, we'd be happy to do that for you. And the last slide here is about seeing us at RSA. We expect to have a great showing this year. So there you go. Again, thank you for attending and your time. I appreciate it.
Awesome. Thank you so much, Seth. I really appreciate it. And with that, we're going to go ahead and close out the webinar today. I want to thank everyone for attending the webinar. We hope you enjoyed it as much as we did. If you registered through VIB with your business email, and if you have any questions for us, you can contact us at gc@vib.tech. But if not, I hope everyone has a wonderful rest of their day. Bye, everyone.